Hello everyone. Let's talk about microservice communication pattern, API gateway. If your frontend is calling a lot of microservices just to load one page, then we have a problem here, an architecture boundary problem. We need to have an entry point that removes this tight coupling. Let's take a simple example of an e-commerce application. When a user opens the app or website, the page they see looks simple, but behind the scenes, a lot is happening. That single page is actually composed of data coming from multiple backend services. To fetch everything it needs, the frontend makes separate calls to the order, invoice, inventory, payment, and shipping services. Every service handles authentication repeatedly, and when one of the service breaks, it can impact the whole system. Let's say the invoice service is down for any reason. As we don't have any mechanism and front-end directly gets data from there, the system breaks. Now imagine doing this for every page, for thousands of users at the same time. It is very complicated. What if we have something in between the front end and the back end that loosens up the coupling and helps us get rid of the spaghetti architecture? The API gateway calls appropriate backend service based on HTTP method, headers, API versioning, query params, user identity and roles or traffic rules. But for now, we're just scratching the surface. These problems can not only be solved by API gateway, there is a whole lot of other mechanisms in microservices that is required for a system to work seamlessly. Let's talk a bit about the API gateway. Benefits of API gateway. It decouples front-end from back-end. The front-end now only calls the API gateway. It provides centralized security, so the back-end services don't need to worry about the authentication and can only focus on the domain logic. It helps in reducing the network calls. In place of 4 different calls, now we can just get the work done in a single aggregated call. The API gateway typically handles authentication and authorization, request routing, response aggregation, rate limiting, throttling, caching, and protocol translation. Now, before we get too excited, let's talk about the risks. The API gateway can easily become a single point of failure, especially if it's poorly designed or not highly available. Another common mistake is letting the gateway grow into a mini-monolith. When too much logic creeps in, it becomes hard to maintain and even harder to scale. And finally, if all traffic flows through one gateway, it can turn into a performance bottleneck when the system is under heavy load. But here's the good news. All of these problems are avoidable. Keep the gateway thin. Scale it independently. And most importantly, never put business logic inside the API gateway. Treat it as a traffic controller, not a brain. Now, when it comes to implementing an API gateway, you'll find several mature options in the industry. On the cloud side, Azure API Management and AWS API Gateway are commonly used. They provide managed gateways with built-in security, throttling, monitoring, and scaling. If you're looking for a more platform-agnostic or self-hosted solution, Kong and Nginx are very popular choices. And in the Spring ecosystem, Spring Cloud Gateway is widely used for building lightweight gateways in Java-based microservices. The key takeaway is this: the pattern matters more than the tool. Choose a gateway that fits your platform. So when should you use an API gateway? Use it when you have multiple clients, need centralized authentication, or your backend services change frequently. It also helps when you want a clean separation between front-end and backend. But skip it if you only have a few simple services, if the system is internal only, or if you're still in the early prototype stage. Good architecture simplifies, it doesn't slow you down.